Hi everyone, I'm Gaurav Bhaiya, and today we'll cover this lecture for our Java placement series day 2. And I hope everybody have understanding from day 1 that what we have covered, right? So now you know how Java was created, right? And what was the requirement for it, and how the fundamentals were designed, right? And also you're aware about the fundamental things like variables, data types, etc. All these things, right? In this particular lecture today, in day 2, what we will do is we'll try to have few concepts. One is the operator, second is the control flow statements, including loops and conditionals. But also we will cover one extra topic which I haven't written here because I'm not covering in that detail, but only the necessary part of the arrays and the strings. There we will learn how you can create the array like 1D or 2D array or maybe the 3D array, right? How you work along with the strings, right? And what are variations are available for the strings, like string builder, string buffer, right? Why they are available. So all these things we'll try to explore. So let's begin one by one. But before I begin, tell me, have you done the practice from the last day? Have you done? Right. And are you confident now? Are you confident now, like on somewhat concepts that what is programming, what is translator, what is data types, variables, why Java, all these things? Are you done with your setup? Do let me know in the comments. Huh? I'll keep waiting that how much you really enjoyed this particular lecture or not. But anyway, if somebody want to ask something to me, you can connect me on LinkedIn. Search Gaurav Pandey Mentor, you'll get me. Okay, you'll find me. Perfect. Now we will begin. Now we will begin. Here in operators, basically what is operator that I'll tell you. I hope everybody have an idea, but I just want to give you one liner meaning of it. So operator is nothing. They are some kind of symbols that will perform some operations. So they're what? They are symbols. Okay. Symbols that perform some operation. Perform some operation. Perfect na? Perform some operation. Operation. Makes sense to me, right? But how? I'm giving you an example. You remember in your class, maybe probably in one or second class when you were copying some calculation from others' copy. Is it so? I don't think so, but maybe in some case. So here I've written a plus b. This is what the plus is the operator. Or if I have written 2 plus 3, plus is the operator. Or I've written 6 minus 3, minus is the operator. So these things are the operators. You see, these symbols perform some operations. And that's why we call it operator. So simple meaning. I hope making sense to everybody. Symbols that perform some operation. That's it. Easy peasy na? Easy peasy. Perfect. How many types of operators are available? Now few people will start like arithmetic assignment. Yes, they are operator, but you have to categorize them based on the operands. Then how will you? So based on operands, we have three category: unary, binary, and ternary. Okay, unary means single operands. Unary means single operands. Binary means two operands. Like these are binary. Look at this, A and B. We had two operands. So this was the operator, and the operations we're performing on the element. Those are the operands. Okay, those are the operands. Now here ternary means you will have three operands, basically three window where you will do something, right? So that is the ternary thing. We'll go one by one, one by one. Here in unary operators we have two things: increment operator, decrement operator. They also have a category. If I talk about increment, you will have pre increment and post increment. Two things: pre and post. Pre and post. So pre, you understand the meaning of the pre? Means already do a prepayment before getting any service, right? So that is a pre-increment. But do a payment after getting the service, that's a post payment. So basically pre means doing something earliest, and post means doing something later after doing something, right? So here how this look like: pre-increment is a plus plus. So this is what nothing, it is symbol like plus plus, and this is also plus plus. But how will you differentiate them? Pre means previous. Pre means previous the operand. Previous the operand, right? Before the operand. That is the thing pre. So here I'll write, let's say, plus plus a. That's a pre increment. Again, if I write a plus plus, tell me what it will be. After means post. After means post. Or post means after. But it's a rhyme. Something like pre, post, pre, post. But let it be. But anyway, I'm just giving an example how this works. This basically increment the value by 1. Increment the value by 1. So here, for example, if I had a equals to 5, in this case, this plus plus e, if I print it, if I write system.out.println, and if I print it, I'll get directly 5. In the next step, if I do system.out.println a, I will get 6. Why? Because first it will, sorry, here you will get the 6 in the first step. Here for this, you will get in the next step. So here eventually, because this is pre. So if I do system.out.println plus a, I will get 6. Why? The value is increased by 1. Then it printed, then it utilized. So that's a pre. Post means first use it, then increment it. So I'm assuming if I have a equals to 5 again, and if I do this system.out.println a plus plus, it will print 5, and in the next step if I print it again, then I'll get 6. Why? Because first we utilized here, first utilize, then increment. Here first increment, then utilize. That's a pre and post. We'll see the example also. Okay, we'll see the example also somewhere. Now here decrement operator. So how we will do a decrement thing? So decrement operator also, you have two categories, same like that. Here you will have pre and post. Pre decrement or post decrement, same meaning, nothing different. Pre and post. So pre basically means first do the decrement, then utilize it, like minus a by 1 only. Okay, subtract by 1 only. Again, post means first utilize, then subtract. So this will be a minus minus. So let's go to the VS code. There we will understand. Okay, there we will understand if somewhere I get that particular thing. Here I'll open my VS code and I'll open our Java placement folder. Yeah, I guess here I should little bit categorize this thing, right? So I'll create a folder that's a day one or something. And in day one, I'll move all these files. Okay, I'll move all these files. So yeah, why this is not selecting it? But no worries, it will select. I really don't want to open it. I'll just drag these files in this. Move, but this will take time. Probably it's not selecting in my system. I don't know why, but it's okay if this is not selecting. I'll move one by one. Okay, perfect. Let's go here. I'll just organize it somewhat. Uh, Perfect, and I'll put it here. Perfect. Now the thing is, I'll have another folder which is day two now. Day two. In this folder, we'll create a file which is, let's say I'm writing unary.java. Unary.java for the unary operators, right? So here I have, here the package thing I forget to tell you, like what is package. So package is something which, what it will do is it will put all your class file in one folder, like directory. So for example, you have a C directory, there you have multiple folder, multiple things. So basically what Java does is that it will, group all the classes into one package, why which if you in future, if you want to give all these files to somebody else, like we utilize it. You remember we imported a scanner class, there we had a util package. So in util package, we had multiple classes, now we can import it. So that's the package thing. But anyway, I'm not declaring it as of now, right? But anyway, I'm just saying that you should explore this more, that what is package and how everything works. Okay, but package are very important when it comes to like transfer the code, right? If somebody want to use it, they want to import it, then package plays very crucial role to organize your entire class of multiple things. Okay, so here I have this public class in area, right? Public static void man. A time will come when you'll know the meaning of this public static void. Very soon time will come, huh? But now know this man method is something which will be responsible for executing your code, the entire code. Okay, so now here what I will do is now I'll just take a variable integer type. Let's say age equals to 5 I have. Then what I'll do south means system.out.println, and here I'll write a plus plus. Can somebody tell me what it is? After we're getting means post increment, and then I'm printing here south a. What I will get? Here I will get 5. Okay, here I will get 6. You know why? The reason is first we utilize it, then we print it. Okay, that is the thing. First we utilize it. So the utilization of a was 5, then that was done by incrementing it. In the next line we have the 6. Again, what if I have b is equals to, and b is equals to, I have b, or not b, let's say 6 or something, and here I do south and pre-decrement. Okay, pre means earliest, early, or I'll do the increment. Okay, so plus b. If I do right now, here you will get 7 automatically. On the new line also you'll get the 7. Okay, so that is the thing. So if I'll do print south and b, that will be 7 again. Why it's a pre? Why it's a pre? Right, that is the thing. Now here again, if I talk about the decrement, the same thing you can do for the decrement also. So here, if I write here, let's say int c equals to, I'll just give example of 5, and here if I do south, I'll do c minus minus. You know what eventually will happen? Here you will get 5 itself, and on the next line, what you will get? Tell me. You will get the 4, right? Because it's decremented now. Making sense, I guess. Making sense to everybody. And then again, if I do that thing, let's say a pre-decrement. So here, let's say I have D equals to, I have let's say 5 again, and here I'll do south, and I'll do pre-decrement D. Now here I will have what? Here I will have the value as 4, and on the next line also I will have the 4 if I print it. If I print it, making sense to all now? Making sense to all, right? Making sense, but not here. We won't have 4. What you will have here? Okay, 4 we will have anyway because of this 4 we will have. So let's move CD in my folder day 2, and here I'll write Java C. The file name was unary dot Java, then Java, and again I'll execute that unary thing. Perfect. Now look at this. 5 we are getting, 5 and 6 we're getting. Look at why? Because first utilized, then incremented. Then we're getting 7, 7. Right. I hope this is clear to everybody. Then again we are getting what? Here we are getting 5. Then again this will become 4, right? Because decremented by 1. And again here, look at this. We're getting 4 and 4. Make sense now? I hope makes sense to everybody. So that's how unary operators work. Making sense to everybody. We'll utilize it in future, huh? In loops a lot of time. Now it comes to the binary operator, which means that you will have two operands. You will have two operands. And binary operator have a category of arithmetic operators, relational operators, logical, bitwise, assignment operator. So here what we will have, you will have two operands. Two operands. Yeah, I'll just change the spelling. Two operands. Here. Operands. Perfect na? Perfect? Let's go one by one. Let's go one by one. Arithmetic basically, you remember the childhood when your mother was scolding at your home and the madam was scolding at college and girls was laughing on your calculations. That was the time here. I know you went into the depression. Now come back here. You can smile on that particular thing. It happens. So now here, basically arithmetic operators plus addition, subtraction, multiplication. So here the symbol is that is star sign in your laptop. That's a multiplication here. Then divide, then modulus. Modulus is nothing, it's a remainder. So plus basically means adding something. For example, 5 plus 2, this becomes 7. Here this is subtraction. Let's say 5 minus 2 becomes 3. Again, this is multiplication. 5 multiplied by 2 becomes 10. Okay, and again 5 divided by 2 becomes what? Because it's an integer value, we're doing integer level of division. What you will get? 2 2 ja 4. But 2.5 is the actual answer, but you will get 2 here because it's an integer. Now here you have the percentage, and percentage will give you the modulus. So if I write a 5 modulus 2, you will get 1. Why the remainder is 1? The remainder is 1. It will return the remainder. It will return the remainder. I hope this is making sense to everybody. So that was the arithmetic operator. We'll do practice one by one, huh? We'll do practice one by one. Or should I create a file or something? But anyhow, I hope you understood this particular thing. I don't have to do that level of practice. Again, relational operator. A relational means it will tell the relation of Mohan and Karan in the class, or Mohan or Geeta somewhere anyway, or maybe Mohan or Karan was very good friend, right? Mohan or Geeta was also very good friend, so that level of relation. Or you'll say Mohan Karan, like Mohan was taller and Karan was smaller. Let it be here. So now here that's how we compare somebody, right? So that's a relational or conditional, whatever you say. So here somebody can be equal, right? Somebody can be lesser, somebody can be greater, right? So these are things are the relation, right? These are the things that relation. Perfect. Or conditional. So here this double equals to used to compare. Okay, this is, let's say, 1 2 double equal comparison. You'll do the comparison. Okay, so now you're comparing something, and now here this thing, like here this is greater than. So basically the meaning is that here I'm just telling you, let's say I have, for example, I have a equals to 5, I have b equals to 6. So here what eventually they will always return the boolean value, huh? Always the boolean value, that you need to remember. So now here if I write here a double equals to 5 b, in that case, what eventually will happen? You will have false. Why is that? Because they are not equal. Again here if I write like this, so that what it will give you, it will give you like a is greater than b. Is it true? No, it's a false. Again third, less than. So now age less than b. Yes, it will be what? It will give you true, a boolean value. Again fourth number, maybe I'm asking you that greater than or equals to, greater than or equals to. So now here a is greater than or equals to b. The answer is false. They are not even equal or greater, right? None of them, then that's false. Again, another thing I can have is, let's say they are less than or equal. Yes, that is true because they are less than. So now here is less than or equals to B. In that case, it will come true. And again, let's say sixth number, what I can have else? Uh, Not equals to, right? Not equals to. So this is not equals to. In this case, if I write A not equals to B, the answer is true. Yes, they are not equal. They are not equal. So that's what we are doing, a comparison. But here, one thing I want to tell you: what if I have to compare a string? Will it work? The answer is simply it should not work. Okay, the thing is, basically, I'll tell you when time will come for the strings, I'll tell you the differences. But this is eventually for the strings. Sorry, for like characters and the other numerical values, but not for the strings. Time will come because in Java there is a concept called string pool. Okay, and I will tell you what the meaning of it. Let it be time. Let time come. Right, but I hope now everything is making sense to everybody. Right, this is making sense to everybody. Yes or no? But yeah, I know some people are feeling sleepy. You're watching this lecture on a phone, like styling something. Yeah, I'm just watching. I'm enjoying. That's not a cool thing. You probably won't learn a lot of concept. You have to take proper laptop or table and chair, table and chair. Okay, something like that. Perfect. Perfect. Now here you have logical operators. So logical is something like you will have. You remember the logic gates in 11th and 12th? Do you remember? Right. So the few people will say yes, I had AND gate, OR gate, right? Not gate. So all these things. So you have the same thing here in the logical operator. So here you have AND. Here you have, we call it AND operator. Okay, and this is OR, double pipe sign, OR operator. Then you have this thing, not, and we call it not operator. Okay, so how these things work? So and basically say, if I have like, for example, I have something like here. You have to understand truthy and falsy value. So numbers are the truthy value and strings are the truthy value, but empty string is a falsy value. Okay, so just search for like truthy and falsy value in Java and you'll get it. Okay, I'm just pointing out because covering everything is not probably possible, but I'm just giving you the reference that you need to learn this as well. All right, if wherever it required and deeper. But right now you understand falsy value means like empty string or something. So that's a falsy value or not a zero, all these things. Perfect. So now here, let's say I have here two things. I have two variables. I'm just creating a table to you for you, right? Okay. And you'll have that memory from your college, which you already learned. So here, let's say I have variable A, I have variable B. Okay, I'm assuming true or false. I'll denote one as true. Okay, I will denote one as true, and let's say I'll put like one as true and zero as false. Okay, so now here I'm writing A and B. Then I'll write A or B, and last I will write not A. Okay, so now let's say 0, 0, 1, 1 I have. Okay, here I have 0, 1, 0, 1. So now 0, 0 becomes, if your both values at left and right both are false, and will give you false. If any one of the false, and will give you false. Anyone false, because 1, 0 becomes 0. 1, 1 when both are true, left and right both conditions are true. In that case, will return true. In this example, for this or thing, what eventually will happen, if any of the thing is true, it will give you true. So here 0, 0 are both are false, can't do anything. Now again 0, 1 becomes what? It will come 1, right? So now here it's 1. Why? Because anything is true, that's a true. Anything is true, that's true. Perfect. Now 1, 0, 1, 1, 1, 1. Now here comes to, for the like not operator, it will just reverse. So if this is true, it will make it false. If that is false, it make it true. So 0 become 1, 0 become 1, 1 becomes 0, 1 becomes 0. So that's how they work. That's how they work. Okay, I'll show you the real-time examples, don't worry. Okay, we'll see in the practical ones, we'll finish these operators. Okay, now here we have bitwise operators. The same name we have given there now for the logical, the same name we'll give here as well. That here we have AND operator, but one AND. We have log OR operator, but one pipe sign. We have NOT operator, but that's this thing. So not. Then we have JOR operator, this cap sign. Okay, I'll tell you how they work. Okay, how they work basically. So now the thing is, they works on the bits. Basically, these works on the differences. You need to remember, works on Boolean. or truthy falsy value, right? Here they works on the numbers and bits. Works on bits. Works on bits. Like if you're passing the number, now they'll convert into bit, then they'll work. Okay, so they also have the same meaning. They also have the same meaning. So I'll design somewhere here. So here somewhere I'll design, and probably I hope that is visible to everybody. Here A, I'll put B, I'll put A and B, I'll put A or B, I'll put not A, okay, and I'll put JOR, A, JOR, B. So now the thing is, let's say I have 0, 0, 1, 1. I have 1, 0, 1, 0. Okay, so now A and if any of them are what? Any of them are, if they, any of them are what? If they are false, it will become false. Same as that particular thing. But they are working on the bits, which means that 0 and 1 become will what? They will become 0. 0, 0 will become 0. 1, 1 will become 1. Okay. But now the thing is, when it comes to the addition, now I'll tell you how you add them. Don't worry. So now here 1 0 becomes what? 1 0 becomes 0, right? Which means like this. Again here for come to the or, same thing. 0 1 1, 0 0 0. If any of them are true, it will become true. Okay. Here for not, just reverse it. Just reverse it. 0 become 1, 0 become 1, 1 become 0, 1 become 0. JOR means, similar will be, like the thing is, basically JOR basically says that if you have 0 and 1, so what eventually will happen, like similar will be cancelled out and different will be true. So here 0 1 becomes 1, 0 0 becomes 0, 1 1 becomes 0, and 1 0 becomes 1. Okay, so the thing is basically, if you have the similar, if you have the, like, both the things are similar, they will come false, but different will be true. Different will be true. So if you have 1 0, they will become 1, but if you have 1 1, they become 0. So that's a JOR operator. Perfect. Perfect. I hope this is making sense to everybody. Now assignment operator. Now comes to assignment operator. Okay, so now assignment operator is something which assigns the value, right? That is equal only. Equal. So here, what is this? It's a equal sign. So what I'm doing here, you remember I used to write here like this, int a is equals to 5, which means I'm assigning the value of a, like value 5 to a. That's the assignment. But also there are variations like plus is equals to. What does it mean? If I write here a plus is equals to b. So the actual meaning of this is I'm writing a is equals to a plus b. That's the actual meaning. So first it will be solved, then it will come to here. Okay, then it will come to here. Now here another thing is minus equals to. So if I write here like this, it means simply that a is equals to a minus b. So first we'll solve, then it will come to the left side. Again here, if I write here multiplication equals to, so that means that if I write here a multiply by, like this, so simply means a multiply by b. Okay, and similarly the division and modulus, everything. That's the assignment operator. I hope this is making sense to everybody. And then we'll move to the ternary operator. But before we move to the ternary operator, I just want to give you the practical of it. Okay, I just want to give you the practical of it one by one. Okay, so here we'll go to VS Code somewhere, and here I'll write binary.java. Okay, binary operator dot java. I'll create a file here. Okay, and I'll remove the package. I don't need it, but let it be this time. But anywhere, package you already know, and I don't want to add another concept here. So now public static void man. But if somebody needs a detailed lecture on the packages and other things, do let me know in chat. I'll cover in the next lecture. Okay, so now here I'm assuming that I have variable int a, where I'm passing 5. Okay, and int b, where I'm passing value as 6. Okay, so now here I just want to show you the. I guess we had taken 5 and 2 in arithmetic, right? So I'll write arithmetic operators. Arithmetic operators. Perfect. Here I'll write south, which means that a plus b, addition, and multiplication, division, or subtraction, you know, but a division I'll write here to show you something. That if I write here a minus, like a divided by b, here I'll just give you some message also by which you understand. Okay, you understand what's happening here. So I'll give a message, and whenever you are putting a message along with the variables, remember to add the plus to concatenate your answer. So now here, let's say I'm just writing addition. Okay, add. And here I'll write division. Okay, here I'll write the division. So I'll write division and division. Perfect. Perfect. Now here another thing is a south. I really what want is I want a modulus. Okay, so now I'll write here. I'll write mod, and then here I'll do like a modulus b. Perfect. Making sense to everybody? Yes or no? Making sense to everybody? Perfect. So now here what I will do now, I'll just execute this particular thing. So Java C, the file image binary, and now here I'll write Java, I'll write binary. Perfect. So now look at this. Add if like this is coming as oh, the problem is not it's added directly as a string. So I have to put in this braces. Otherwise, it's a concatenating first and making it a string, and that's why it's not coming. Okay, that's why it's not coming. So but anyway, now what will happen eventually now? Here a concept come, we call it operator precedence. Okay, operator precedence, which basically tells you that which operation will be performed first. Okay, so you remember the Bodmas bracket, right? That Bodmas name, that Bodmas rule. Okay, that applies somewhat here, but in not in all cases. So I'll give you a reference from where you can see all the operator precedence number, because that you have to remember. Okay, that you have to remember. Don't worry. After this, I'll give you that particular reference. So here now, if I run this again, now if I run this again, so here I haven't given the access, but anyway, it's coming add 7, which is correct. Division, which is 2. You remember what we had? We had the integer value right here automatically, but that's not certain. That shouldn't be a case. You have to put a float here. Okay, you have to put a float here. So float, basically you're telling explicitly that convert to a float because you want that output, right? You want that output. So now if I do this now if I do this mod is coming 1. Why? Because the remainder is 1, which is making sense to me, perfectly making sense to me. So now here we are doing type oh, again that is a problem. The thing is why? Because after it's an operation, once this is done, then we are converting to float. So not here, we'll put it here within this. Okay, within this. Now probably this will give me the correct answer. So now look, it's coming 2.5, which is correct now. So why that was happening? Because after doing the operation, you're trying to convert into the float. That's why coming 2.0. But now here, explicitly you're telling that do this operation the floating points. So that's why we're getting 2.5 now. Making sense? And mod is coming 1, which is remainder, right? Perfect. Now here the another thing what we were having it, we were having relational operators, correct na? That's what we were having. So now what you will do here, you'll write south. I'll just probably write 1 or 2 and you'll understand it. So if I now do a equals to, what you will get false, right? So I'll write some message also which you understand it, but always remember to put a bracket here. Otherwise what will happen, they will be added to the string, right? And you won't get your output. So now here let's say equal. So here I just want to leave some space on this thing where it should look good in the output. And now here let's say I'm putting another thing south, and here less than, something like this I'm putting. Okay, so now here I'll write here like this, something like this. I'll write here uh basically let's say a, or let's say I'm writing here b is less than a. Okay, that's what I want to write. So now if you'll see now, I'll just run this. So Java C, then Java. So now if you'll see now, equal they're false, but less than is they're true. So B is less than the A, right? B is less than A, which is true. So that's how you work with the relational operator. I hope this is making sense. They will give you the truth, like true or false value only, means the boolean values. That's it. Another thing. What was the another concept that we have covered after this? We had relation, then we had logical. So now it comes to the logical thing. Okay, I'll give you the logical. So now for the logical operators, what I need is I need a true or false thing. So I'll have a boolean. I have boolean value. So let's say boolean I'm saying um C. Okay, one is false. Okay, I'm saying boolean. Another is D. I'm saying it true. Okay, now I'll just show you how they work. South, and here I'll write probably let's say C and D. That will come as false, right? But what if I write south C or D or D? That will come true, right? And again, if I do not south not C, that will come true because false will become true. Perfect. So now I'll just run this. And so Java C compiled and executed. Now look at this. First it's coming false, then true, true. Making sense to everybody? Making sense, right? That's what the logical was. And now after that we had the bitwise operators. Perfect. So now here what I will do now, I'll just have, let's say, um, I will have few values like say int, and I'll write 0 and 1 to get the bits only. Okay, nothing more than that. And here I'll take this int, and I'm taking, let's say, a is equals to 0. Okay, and oh, a is already defined now. That is the problem. So we cannot have again. So this time I'll take e and f. So int e and int f, which is 1. Now I want to write south, and I'll write a bitwise operator b. Eventually, what will happen? 0 and 1 because of and will become what? They will become 0. I'll just show you somewhere. Okay, don't worry. So now here, there's somewhere I want to give the message. Let's say bitwise operator, you understand it directly. Bitwise operators. Perfect. Now here we will write this thing south, and then I'll write here a or b, and then I will write south uh, not a, not a. So here the not is different, huh? Again south, here I'll write a jor uh, a jor, basically b. Perfect. Now you see not is a unary operator, that you have to remember. Not is a unary operator here. Okay, so perfect. Now here, that's not a binary. So now here we go. So here what eventually is happening now, the bits are converting, but for that you have to understand multiple things. I'll tell you how they are coming. Okay, don't worry. So here a and b becoming what? They are becoming 0, but they're comparing the bits, not the number. What they're converting? They are working with the bits. So here this a and b, like 0 and 1, become 0. But how this is coming 7? How this is coming 7? This 1 and 0. Okay, so eventually, what is happening here is you're having this 0 and 1. They are making it 1. But now the thing is, they are converting into the bit, then they are working with this. Okay, then they are working with this. That's why it's coming 7 here. So for that, we have to understand it's a binary representation, how they are working. Okay, that binary representation. Or I'll take a simple example, which I'll just give you a complete example, not 0 and 1. I'll take 5, or let's say again, I'll take probably 2. Now I'll tell you, because I'll tell you the conversion also, because 0 and already converted, so you won't have lots of meaning. I guess I have compiled it. If yes, perfect. So now I'll tell you how they're working. It's being saved now perfectly. But anyway, I'll tell you how this is coming. Okay, 0, 7, -6, and 7. How this is coming. So let's go to our PPT, and here we'll come to the bitwise. So here what I was doing is I was taking age equals to I was taking age equals to 5. Okay, and here b is equals to, I'm taking 2. So now you know how you convert our integer to this bitwise operator. That's important thing. So basically now what eventually will happen here now, I'll just convert this thing. Here I'll convert a 5, and 5 I'll put 2 here. So 2 2 ja 4, right? So here how many times? Sorry, here 2. But remainder always put it here. Remainder always put it here. So now again 2 1 ja, right? So how many times? 1 time. But what is the remainder? I should divide it completely. So remainder you'll put it here, and once you'll do in this reverse way, now you will have your binary representation. So 5 is denoted by 101. It's a 101. Again for 2, you see this 2. So let's say 2 here, somewhere 2 here. So put it 2. So again 2 1 2. Yes or no? And remainder 0. Divided completely, this will be 10. This will be 10. So eventually we can write it 1010, right? But the thing is, in 32-bit system, all the numbers are denoted as 32-bit. All the numbers are denoted as 32-bit. So eventually what will happen when you comes to here, in this operation, when you have this thing 101, and this thing will happen 010. Here all previous values are 0. All previous values are 0. Here multiple values. So that's what you have to remember till 32 bit. Means all these correct number of digits will be 32. So that is the thing. That is the thing which you have to remember. So now if I put end here now, basically I'll ignore these things because they are all by default 32. So I'll just take them only. So now this becomes 1 0 becomes what? 1 0 because it's the end. So 0 0 1 becomes 0, 1 0 becomes 0, and all of them are 0 0. So they will become 0. So all these value become what? 0. That's why we were getting what? For and we were getting 0. For and we were getting 0. You remember? For and we were getting 0. For or eventually what will happen? For or eventually what will happen? So now yes, somewhere here I have to erase this now because I have limited space. So I'll erase this table. I hope I will have sufficient space. Artist. But anyhow, before just go 1 minute back and take the screenshot if you want the complete notes of it. Okay, so now here let's say I have this thing A or B. So perfect. What I'll do now? So I'll put the number here. So I have 1 0 1 1 0 1, and here I have 0 1 0. And I'll put an OR operator here. So eventually 1 0 becomes 1, 0 1 becomes 1, and again 1 1 becomes what? Like 1 0 becomes what? 1. And now at the end 0 0 0 0 0 they become 0, right? Because 0 0 becomes 0. So here you have 1 1 1. How will you convert to the original number? How will you convert to the original number? So here the thing is you have to multiply by 2. Okay, by making it power. So here, like here you start to the power 0, okay, plus multiply by this particular thing, 1 multiply to the power 0, 1 multiply by to the power 1, plus 1 multiply whatever you have, bit here, multiply by it to the power something. Right, so it will start from 0 1 2 3 4, like this it will go. So to the power 2. So now if you get the sum addition of them, they becomes 4, plus this becomes 2, this becomes 1. So if you calculate, this becomes 7. So that's why the another one was coming 7. If you'll see the such coming 7. You're getting my point? And similar for this not. Similar for this not. But for that purpose, you have to understand lots of things. Lots of things. One's complement, two's complement, and multiple things for the not. So here I have 5, which is 1 0 1. But eventually what I have at starting, all values are 32 bit, all are 0. All are 0. So I'm assuming rest here how many? Total 29 are 0. Right, 29 0, something like this. So that's what I have as of now. If you are performing not, you will invert the bits. You will invert the bits. So basically this 1 will become 0. Okay, this 0 will become 1, and this 1 will become 0. Okay, and now this is how all our zeros, will become what? Tell me. All our zeros will become what? They will become 1. And if at the end, how many times? 29 times. If at the end the 32 number bit, if that is 1, that means negative. Otherwise that is positive. Okay, otherwise that is positive. So what you have to do, you have to do 1's complement. Okay, you have to do 1's complement, which means that you have to invert the digits. 1's complement, you have to invert the digit. That's a 1's complement. Okay, so now here invert the digits. So basically what eventually will happen here, you will get, and you remember this thing, huh? You remember last, the original bit, the original number, we have this thing. The original number, we have this. But how will you convert to the actual number? That is my question. In the original, last bit will be 1, because previously we had 29 times 0. You remember? And again here 29 times 1, because all 0 converted to 1. So because of this, number will come negative, because 32-bit number bit is 1. If that is 1, that means number will be negative. Otherwise, if that is 0, number will positive. So here what eventually will happen, you will do 1's complement, inverting all the bits. So now all 1 will become 0, means again 29 times 0. And then after that, these three things, you will have 1, you will have 0, and you will have 1. 2's complement, not 2's complement, add 1, which calls 2's complement. You want to get the original number. So now eventually what will happen, this 1 1 becomes what? 0. Addition of binary, you have to understand this. 1 1 becomes 0, carry 1. So carry 1. 0 and 1 becomes 1. Again, what eventually will happen here, by default you don't have anything, that becomes 0. So means 1 and 0 becomes 1. Right, and all our things are remaining same as 0 0 0. So now if you will convert, this will be 6. How? I'm just telling you. Look at this. Look at this thing. You have 1, you have 1, you have 0. So to the power 0, to the power 1, to the power 2. Multiply by 0, because whatever bit you will multiply with it. So here this 0 multiply by 1, plus here 1 multiply by 2, here plus 1 multiply by 4. Now this becomes what? 4 plus 2 plus 0. This becomes 6. And because in our original number last bit was 1, so this will be -6. This will be -6. I hope this is making sense to everybody. Yeah, it may be complex thing, complex to understand, but it's important. Okay, it's important to understand. So now look at this. This is coming as -6. But understand it thoroughly, huh? You have to do ones and twos complement. Here what we did, we performed the not. We performed the not operator, right? We did not operator. And we assume that it's a 32-bit system, right? So you have 32-bit integer because that's an integer value, 32-bit. You remember from the data type thing, right? So all were the 0000. When you invert it in, they become 111. So the last bit will decide what will be the symbol. So the symbol was, because of 1, we have symbol as negative. Right now you'll do ones complement, inverting all the digits. We call it ones complement. Then again adding 1, we call it two's complement. Okay, so that's how you get the original number. I hope this is making sense to everybody. Right, you really enjoyed this particular thing. Now another thing comes as this thing, JOR operator. How this JOR works. JOR works. So now what I will do now here, this JOR thing. Where do I put it? I'll just erase it. You can take the screenshot, huh? I'll just erase it for getting more space. Let's say here. Let's say here somewhere. Okay, I'll take this thing. I'll take this thing. What is like here, right here. So we have this 101, which is 5, 2h 01, but eventually I'll assume, sorry, it was 10. So I'll assume like 0 at the starting, and I have just JOR operator to perform. What will happen? Similar will have 1, and rest will be having as like if you have different, they will be 1. Similar will be 0. So 10 different, get 1. 01 different, get 1. 10 are different, get 1. So what was the value? Remember that was 7. That was 7. We already converted here, so I don't expect that anybody forget this. This is 7. So that's why we at the end we're getting 7. I hope this making sense to everybody. So that's how you work with the bitwise operators. Perfect. Now another was the assignment, which you already know. Yeah, we already done this. Right? We already done this. That you already know. And anyhow, you'll utilize in the examples as well. Right. But anyway, I'll just show you one example of this, how this is working. So now with the, I guess E and F was also 5 and 2, and this is also 5 and 2. That's why they're coming same, because here I've written A and V and V and V. Right. Eventually they worked here. Otherwise, I could have something else. I would have something else. Perfect. That's why they worked. That's why they worked, because they have the same values. But here, anyway, I wanted to put the E and F. E and F. That's why mistakenly I've written it. But here we have F. Here we have E. Okay, here we have E, and here we have F. Perfect. So now here, if you run this now, somebody will say like maybe this is value changed, so now nothing is changed. We have the same output. Now perfect thing. Now here we have, let's assume that you want to perform, let's say here a variable I have E, F, G. And here I'm writing G plus or plus equals to 5. You know what will happen? But I have to define the G first, which I haven't done. So here, let's say first I have G equal to something. Okay. So G equals to I have probably 5 already. And now here, now what I'm doing is now I'm writing here G plus equals to another 5. So eventually what will happen? Tell me. If I'll do south here, that will come 10. That will come 10. Why? Because adding another 5 and then pointing out. Perfect now? Making sense to everybody? This means that G is equal to G plus 5. So previous value of G was 5, and another the new value of G is 5. So 5 plus 5 becomes 10. Right? Another thing we are adding, which is 5. And assign, like we are doing assignment right to left, always right to left. And again, one important thing, what you have to do now, just go here and search for operator precedence. Operator precedence is nothing. It's same like which level, like how will you perform the operation, which will execute first. Operator precedence, precedence in Java, and go for MDN. There will be good doc with MDN somewhere if we have, or something else. Any doc, yeah, just prefer it. But they are having in JavaScript, that is the problem. Operator precedence, JavaScript, not JavaScript, I want in Java. So MDN I won't have, but somewhere else, somewhere else. Okay, so take it anywhere. Let's say Oracle Center. So somewhere you will have the operator precedence. Oh, they're saying the operator only. Somewhere you'll find it, don't worry. So here, programming or something. Okay, get it. I hope this is making sense to everybody. So get it somewhere and you will find it. Operator precedence. But you have to remember that order. That's why I'm not covering it, because remembering that order anyhow, that's a manual thing. Right. Perfect. Yeah. Now ternary operator. Ternary operator means we will use the three operands altogether. So now here the syntax is, here you will have uh, a one operator. Okay. So I'll call it op1. Okay. Then probably what I will do is now, if that can be true or false, anything. So if that is true, then this will work. If that is false, then this will work. The other thing. So for example, if I ask you that 5 is greater than 2, which is true or false. So if that is true, I want to say hello. Otherwise, I want to say hi. So eventually what will happen, or I say like 5 is greater than 2, or here I write 2 is greater than 5, something like this. So the thing is, if this is true, then this will execute, otherwise this will execute. That's call it ternary operator. So now if you'll see, look at this. We have three things, and that's why I call it ternary. We call it ternary. Making sense to everybody? Right, we'll see, and we'll go and we'll directly see one simple example to finding out greater of two numbers. Okay. So I'll write a new file, ternary.java .java, and here I'll just write this thing. I'll just write this thing here, which is this. I'll put it here. What it was, int a equals to 5 and b equals to 2. Okay, and here what I'll do now, I'll just write here that south, not sun, south. Why this is not coming? SOUT. I don't know why. I hope that is Java file only. System system dot out dot println. I don't know eventually what happened suddenly to my files. Maybe because of packages or something I've defined here. Oh, I didn't have man function here. I was thinking like what I'm doing. Command X, I'll do public static void man, and then here I'll go. I'll paste that thing. I was thinking like why this is happening. So now if I'll do now system.out.println south, now this will work. Making sense to me. So now here if I write here, let's say A is greater than B. So what I want, if this is true, then say A is greater. Otherwise, I want to say B is greater. B is greater. Make sense? So now if I'll execute this, I'll write Java C here. The file name is ternary.java. Now I'll call it Java, and file name is ternary. So now I'll execute. Oh, because of this package now, this thing happens. I have to call that package name. That is the thing. What the package name is here, where my ternary went, ternary.class. So here I have to put that day2, I guess. Java C day2.ternary. Day2.ternary. Oh, not found it. Let's fix it somewhere, but anyhow, I'll remove this thing as of now. It's going into the package, and that's why it's giving an error. I'll remove it and I'll compile it again, then that will work. Java C, Java. Oh, Java C compiled. Then again, I need to execute this thing, and not day2. I need to execute ternary. Ternary. I hope that was available. So look at age greater, right? Why? Because W of age greater. But what if I put it 1 here? It will give me B age greater. Right. So that's how it works. That's how it works. Perfect. B age greater. Making sense to everybody? Making sense to everybody? Now you're perfect here. But anyway, it's video being long. But anyway, I hope you guys will watch this. So here the another thing is array and strings. So array is something basically, you have group of collection of similar data type. That's what array in Java, group of similar data type. Okay, so now here basically, and you will define the data type. For example, I want an integer array. So the basic syntax to define, like you want to pass directly value, so you will have here int, give an array name, let's say arr, and put the value here. But before that, you have to use this thing, either early, like before it array name, or after it. That's not a problem. So here put the value, let's say 1 comma 2 comma 3. One way. Another way you do with the help of a new operate, like new keyword. So which means that in that case you're defining the size of the array and automatically value will be assigned. The another way can be like this. Okay, it doesn't matter that you put before or after. So now here you put a new, define the data type, what kind of value this array will store, and the size. Let's say the 5. So eventually what will happen? All the value of this array by default will be assigned to 0. 0, comma 0, comma 0, comma 0, comma 0. So that's what the array is. That's what the array. If you want to find the length, put dot length. Okay, dot length is a method if you want to get the length. AR dot length. Okay, now another thing is a string. If you want 2D, just put it a two square bracket here, and within this you can have the value. I'll show you in the example. Okay, so here string. So basically, string is normally you put like a equals to, here you put the string data type string a equals to something like hello. That's a string, right? But also you can do with the new string. So now one question to you. You search like if in Java strings are immutable, which means you cannot change anything. So if what if you want to get the mutable strings, what are the other options? So I have two options: string builder and buffer. They are mutable strings, but what is the difference between them? I'm giving you as a homework. Go and search it. String builder, string builder, and string buffer. Time will come, then I'll explain it. I just want that you should budget this thing. And string buffer. Check these two things. They are mutable strings. Okay. And another one thing I want that you should for the string pool in Java. String pool. I want that you should search this. String pool in Java. Okay, go and search this particular thing. But anyway, I'll just show you the example of this, how this works, and then we'll move ahead. We'll move ahead. Yeah, somewhere here I'll put, okay, internally itself. I won't create any new file. So here I want an array. So int arr. Every in detail we'll cover later on, but right now I just want to give you a few example. So I have 1, 2, 3. So I have this one array. If I want 2D array, I'll put this in this way. If I want something else like arr1, if I want 2D, I have to use this two square brackets here, and I'll put the nested values. 1 comma 2 means row and column, nothing more than that. Comma, here you put like this, 3 comma 4. So it's a row and column it will give me. Now another thing is that if not, even not in this way, I want with the new keyword, I want to put the size only, and later on I'll put the value so that you use the new keyword. I'll just show you here. And let's say as AR means size array. So here basically you put these, like if you want 2D or 1D. I want 1D, so I'll put one square bracket here and int. Okay, and here I can put the size. Here this is type of data, what kind of data you want to store. If you want to store a string, put a string here. You want to store character, put the character here, means char. Okay, now I'll show you how to print it. Directly if you print now, they will come as a hash code. So I'll just show you ARR, then here I'll copy the same thing and I'll paste it on the multiple places. Here ARR, this is ARR1, and this is ARR as ARR. Okay, I'll put as ARR. So that is the thing. Now I'll execute this. So Java C. Already I guess I had done everything here. So I'll execute it here. Look at this. It's coming as a hash code. So you cannot directly use it. For that, you have to import a arrays class from the util package. So that's what we will do here. You come here, write arrays, leave some space by which I'll get automatically import arrays. So automatically you'll see now here we have imported this thing from the util package. So arrays dot to string is a method by which you can print your array directly here. You can print your array directly here. So I'll write ARR and I'll remove from here. I'll remove from here. So now that value will be printed. Same thing you'll do for this as well. Here I'll do for this. Okay, so that's I'll copy the same thing and I'll paste it here. Now you will have the exactly value on the screen because now your array has been converted to a string. That has been converted to string. So here I'll put ARR1, here I'll put as ARR. Okay, perfect. Now I'll execute this. So now compiled and executed. Look at this. Why this is not coming? Because the thing is they are still the nested array. They're the nested array, right? So the outer array has been converted. But what about the internal? What about the internal? For that purpose, we have to iterate it. We have to iterate and print. Iterate and print. Iterate and print. That will be the thing. But I'll tell you how will you iterate with the hello loops. So that's the another concept. String you already know, right? String you already know. Like you write a string, something like this. String as equals to, here you put some value. Hello. Okay. And here with the hello new also you can have a string. I'll just show you something. Okay, I have s here. Let's say s1 here, and I will have s2 here. So string s2 equals to, I'm putting it hello here. Okay, I'm creating another string which is s3. String s3. So here I'm putting new string in another b. Okay, and here I'll put the string. But this is also defines the string. Okay, this also defines the string. So I'll put a hello here. So now the thing is, now I'll compare it. Okay, now I will compare it. So basically I'm comparing it. So I'll put south, and I want to compare s1 equals to s2. Okay, and another comparison I'm doing south. Here I'm doing something like s1 equals to s3. So if you'll see now, everywhere we have value as hello. So all three value are same now, but we will have different outputs. Now look at this. How? Why? The answer is the here somewhere you're having one is true, another is false. Why here it's create like it's comparing the reference. So string pool is something for the normal, like there is a memory in your Java memory and the heap memory especially. So if something is string is repetitive, it will not create a different memory. It will point to the same reference. So now S2 is pointing out to the address of S1. That you will understand from the string pool concept. I cannot elaborate here, but the video will be very long today. So now here this S1 it's storing the original value and as to referencing to it. That's why it's coming true. But here, if you're doing with the new now, it's creating a new address. It's creating a new address to store the hello. To store the hello. But now it's not going in the string pool, it's going in the heap. Within the heap, you have the string pool. So just search the concept in the YouTube what is string pool and read about it, you'll understand completely. Okay. So now it's creating differently. That's why this double equal will not work. So to compare the strings, you have to use dot equals rather than using this double equal. Okay, for comparing the strings, you will use dot equals. Dot equals. Okay, not the double equal. Double equal is used for the character. That's what I was mentioning when I was telling you the comparison operators. So now if I'll compare, now both will come true. Because now you're comparing the value, not the references. Not the references. So the answer is a string pool, how string pool works. So gauge the difference between string with the hello new string buffer and builder. That's what the homework is. Interviewer may ask you a lot of questions from it. Okay, that's the homework is. So quickly I covered it. Now comes to the conditional conditional statements. Yeah, basically the video is being very long, but I hope everybody will watch till end. I just want to see the comment at the end. How many of you have watched that at the end? Do not forget it, huh? At least anyhow, that's what you can do. But if you really like it, like the enjoy the entire lecture, then like the particular video also. Okay, perfect. Here we have conditional statement. So the thing is, conditional means I want to control. Normally, what will happen in Java, your code will execute line by line, like line 1, line 2, line 3. But these control flow statement will tell you what you need to execute. The first line or the last line or in between. You want to control that execution flow. In that case, use the control flow statement. Okay, use the control flow statements. Perfect. So now here you have if else, if switch case. So what does it mean is if basically it basically tells us that if a particular condition is true, the syntax is here you will have condition, here will have condition. If this condition is true, you will execute this block. Some content will execute. Again, if else, if this does not work, then what else? In that case, you need if else and you put it else here. And then if this does not work, then this else will work. If else if you will form a chain, switch case works on the choices. So you'll put a choice, whatever case will match, that will work in the switch cases. And I have limited time, that's why I'm explaining in speed, but I hope you're getting this point. You're getting this point. Here I'll just go and I'll write control flow or conditional. Okay, in control flow you have multiple things like conditional dot Java. Okay, so now here I'll just remove this package, otherwise I have to do different level of compilation by finding that particular file, otherwise I won't get it. So now here what I will do now, here from what I will do, like this thing, what I call public static void main, public static void main. So I have this thing. Now what I'll do, I have, let's say, if I'm saying here 5 is greater than 2, then what I will say now, I will say, you remember the ternary thing we covered the same way, I'll say, let's say I have A and B, two things. Okay, so I'll give you that example. A is equals to 5 and B is equals to 2 and B is equals to 2. That's what I'm thinking of. And now here what eventually will happen, here we have A and here we have B. Perfect na? So the thing is, now I'll write if A is greater than B, in that case I'll print south, and here I'll print A is greater. A is greater. So eventually what is the thing is, if this is true, then this will work. Otherwise, I want the else to work. Okay. That for the else requirement, because if cannot perform both operations, right? So here now I'll put south and I'll put it B is greater. B is greater. So now here this is if else. Again, if you want another condition here, in that case you can have if else if thing. So let's say I have 3 variables here. So I have C here also. So C, let's say 6. In this case, you can have like this time A should be greater than B, and another condition I have to put it here somewhere like A should be greater than B, right? And here I can put like this, and A should also be greater than C, correct? If that is the thing, then A is greater. Otherwise, I have to put condition here if else if. The thing is that A is like B is greater than A. Okay. Along with this, along with this, and B is also greater than C. Making sense? Making sense? Like in both cases, B is greater, right? Otherwise, C is greater. So in that case, you use if else. If you have multiple nested conditions together, you want to check them. So now here I'll put south and I'll put it here C is greater. Maybe you have to slow down the speed or have to practice to understand it completely. Okay, but that's the only way to cover maximum content in short time. So here another thing is the switch case. The syntax for the switch case here, you put the thing here. Look at this. The basic syntax here. You put the value which you want to compare. Okay, which you want to compare. So let's say I will get something value here. So here I'll put a string. I'll put a string, and this string basically I'm creating a restaurant menu or something. So here people give me an input. So let's say I'm writing INP, and here I'll write, let's say, apple. So here somebody want to know the price of the things. So here the switch case, here you put the input, whatever the choice you want to compare with, whatever choice you want to compare with. So here one thing, and here you'll put that thing. That if that matches, if let's say that is apple, I'll tell the price of the apple. So case is nothing, is sort of like if this case is true, that means whatever the value I'm getting in this choice, if that is here in the case, that should execute. That student should execute. So I'll put it here south. I'll put apple is 150, something like this, rupee kg or something, whatever you want to put it here. So that is one case. But what if I have something? I'll tell you the use of break. Okay, I'll tell you the use of break. So here I'll do case, and then maybe I have mango. Okay, so these two things I have, and I want to tell the price of the mango also. I'll put south, and here mango is for let's say 100 rupee or something. You can put a dedicated message. Okay, so now here after that you put the break. I'll tell you the use of break. Don't worry. So here I'll put the break. Okay, why I'm doing this, I'll tell you. And default, why default? If none of case matches, in that case default will execute. So south here I'll put uh, not available, not available, something like this, something like this. So eventually what will happen, if we have apple, so this will match and this will execute. But the thing is, if any of the condition matches, if any of the case matches, if you're not applying break, all the other statement will execute automatically. I'm just showing you how this works. Okay, I'll just this file name is, we have conditional dot java. Oh, I have written wrong. Conditional.java, Java, then I have conditional. Perfect. So here it's going C is greater and apple is 150. Why? Because we have put it apple here. What if I put mango here? Mango here. Then I'll get what? The price of the mango. The price of the mango. Look at this. Mango is 400. So that's how in switch case you work. But what if I remove this break? Okay, what if I remove these breaks? If I don't have these breaks, what eventually, what will happen? If one of the condition matches, all the bottom conditions after below conditions will execute automatically. So I put it apple here now, because this is true, so these two will automatically will execute. Okay, so here look at this, apple, mango, not available, all of them. That's why break is important. And when you match the case, put the break, means stop there itself. So break is something to break the execution of the program. Okay, so here that's why we put the break. That's why we put the break here. But after default, it's not necessary to put. Okay, so here now, if I'll execute now, I'm getting only one. And default is something I'm putting something like app, which is not available. In that case, I'll say like not available. Right, not available. So that's how it works. That's how it works. This switch case work. I hope this is making sense to everybody. Right. Another thing is the loop. Another thing is the loop. Whenever you want to do something repetitive, you use loop. So let's say what I want is now. It's a really being long video, but I hope everybody's watching. Iterative dot java. Here I'll create a file and I'll remove this package. Remove this here somewhere like this. I have this public static void man. I came back here, and now here what I will do now, I want to print a number from 1 to let's say 50. In that case, that's a repetitive task. One thing I can do, I can print system.out.println 1, system.out.println 2 continuously 20 times. Right? We are writing 20 line of code. That's not an ideal way. What you have to do, you have to use the loops. Right? That will do your things automatically at multiple times. So here the syntax is for the for loop. First is the initialization. Int I is equals to, I'm putting, let's say 1 starting from 1, and again condition condition. When the condition will be true, it will keep executing itself. So now here, let's say I want till 20. So here I have to put the condition here that it's a keep executing when the I is less than or equal to 20. And every time what I want to do, I want to increment the value. So first time the value of I will be what? The value of I will be 1, next time 2, next time 3, next time 4. And eventually at the end, what will happen? Value of I will become 20 and it will stop after 21. Like when the 20, it will work, but when it becomes 21, it will stop. So I'll do south here, I'll do I here. Now I'll execute this Java C. The file name was iterative. So iterative.java, Java, and our file name is iterative. Okay, so now look at this. Till 20 we have the numbers. Another is a while loop. Another is a while loop. The same thing as for loop. But here, whenever you know the condition already, that time you work with the for loop. But when you do not know that how many times you have to iterate, in that, like whenever you know how many times you have to execute this huge for loop, because especially you put the value here. And while time will come when you'll implement linked list or something, you'll understand why the while loop is very important to you. But here I'm just telling you the same thing you can do with the while loop also. But here you use while loop whenever you're not sure about that how many times I have to execute. How many times I have to execute. Okay, so in that case, you use the while loop. So I'll put while here. So let's say when the I is less than or equals to, I'm writing here 20, I want to print the all even number. So I'll print here south, but I'll put a condition somewhere here. Let's say if I is modulus of 2, I is modulus of 2. In that case, I want to print it. So modulus 2 means if a number is divisible by 2, it's an even, right? It's an even. So here I'll print the I. Otherwise, I won't. And here somewhere I'll declare my I. And I is equals to, I'm starting from 1. Okay, and here every time you have to do what? You have to do I plus plus. That's what you were doing here. So here the initialization, the condition, the increment, and that's how it will keep working. So now if I execute it again, Java C, Java, it will come like this. Make sense now? I hope this is making sense to everybody. Tried it out, but don't worry. In other videos also, I'll keep using all these things so you will have practice. Right? Just wrapping it in quick way. Again, do while. What is the syntax for do while? So the quite simple syntax. Here it will work at least once, no matter condition is true or false. Okay, so now here do then while, and while you will have the condition. So let's the condition I'm writing here, for example, that 2 is greater than 5. Okay, or I have A and B. Okay, I have A and B. So here somewhere I have int A equals to 1, and I have int B equals to 5. So what I want now, I want to print number between A to B. Right, A to B. So the thing is, this is like I'm writing here, when the A is greater than B, which is false basically, right? In this case, what we need to do is we need to print something. Okay, I want to print these numbers. So south, I will print these numbers. What I will print A in that case, and then I'll do A plus plus. So eventually, first time it will execute, then it will say, oh yeah, that was already false, then I should have stopped this. That's how it will say. Okay, so here if I'll do now this thing, at least we will have one time value. Why one we are having? Then we stopped. Why? Because this was false. So whenever you have the requirement that one time you at least you want to execute it, in that case you use the do while loop. So here the thing is, let's say if I have this thing, what I call it, for example, I write it here. When the B is greater than A, then it will give me the value till here. I'll execute this till 4. Why is that? Because first it printed 1, then it checked here, then it printed again, checked here, when this becomes 5, it stopped. It did not print here. Right, so that's how this do while loop work. Again, the for each loop basically, used when you don't know the length of the array or something. You can use with the array also here. Okay, so let's say I have an array here. So int, I'll just put a random value. Okay, so let's say I have value here of the array 1, 2, 3, something like this, and I want to iterate over it. You remember somewhere we had a 2D array. So that also you can iterate here. So I have this for loop for int I is equals to 0, I is less than ARR dot length. So basically it will tell the length of the array what we have, and I plus, but somewhere I have on the top I have declared that I have to remove that, otherwise it's making a mistake. Perfect. So now here the I is the index here. So array is having the indexes. So basically first value will have 0 index, second value will have 1 index, third value will have the 2 index. Okay, so they have the indexings. So now here I'll do south, and they work with the help indexes only. So here ARR, and I know that you know from the DSA lecture. So here ARR, the I. So eventually what will happen? First time the value of I is 0 means the value available on the 0 index, which is 1, value available on the 1 index, which is 2, value on the 2 index, which is 3. That's how it works. That's how it works. So now if you print now, this will work. If you print now, this will work. So at the end you will see this thing. Look at this, 1, 2, 3 is coming. 1, 2, 3 is coming from here. But right now you know the length. What will happen in future? What if you have the data types? Data type where you don't have the length property, something you cannot get the size. In that case, for each loop helps a lot. It will give you the value without the length. So I'll tell you how you write the syntax for each. So here you have to write the variable that will get the value from the array or any collection. It basically applies for the array, and in future you will have like set or array or array list, all these things. Okay. So here let's say I have the value. Let's say Bella right here and the array name. Just giving a basic syntax. Right now, if you do not understand these things, now let it be. It's okay. Time will come when you will understand it. So now here I'll write south and here I'll put the value. So eventually what will happen if I comment all of the previous values? So that's not a problem for me. Now what will happen now? Oh, array also I've commented. So now I'll just uncomment it. So now I have this array. What will happen? One first time will come in the value, two will then come in the value, three will come in the value. This is the syntax for the for each. So we don't have to use any iterator directly here. Like we don't have to use the length property to get it. It will execute when the length will be ended, it will stop. Okay, so now if you'll do this now, it will give me the value. 1, 2, 3. But anyway, for right now you're having a sort of confusion in this. Time will come when I will tell you that how to use it and when. Okay, time will come. But just this is for the syntax purpose, nothing more than that. I hope yeah, all these things are quite clear. But you can go on the Google, search for the documentation and read them very clearly. Continue basically break it. You want to stop somewhere. That is the break thing. Okay, that's the break thing. So it basically applies for the loop itself. So here I'll just comment it and I'll uncomment this particular thing. Not this, then something else. Then something else. Simply let's say this thing, or probably the first loop here somewhere. I just want to uncomment this. Now the thing is, basically what I want now here. What I want this thing. Let's say that if here basically if I can put the condition that if I equals to let's say 5, then continue. So basically what will happen when I equals to 5 will come now, this will not execute the below statements. It will directly go here. Okay. So what will happen? 5 will be missed here. So now if I run this again, you'll see the 5 is missing. Look at this. After 6 directly, after 4 you have directly 6. 5 is missing because after this does not execute. It went again back. And break is something when you want to stop it. So now if I put it break here, what will happen when you will have I equals to 5? You will stop. That's a break. Look at this. You stopped. You haven't printed it when I was 5. Right. So that's how the break and continue work. I hope this make a quick, fast lecture makes sense a lot. But now what I expect is that you give me the answer of all these things. Okay, the question number 1, the MCQ. Give me the answer in chat along with the question number and the option. I'll be really happy while evaluating. Okay, second, pause the video, read the question, mention question number and answer. Okay, question number and answer. I'll check and we'll discuss probably in the next class if you'll put the answers. Here, this is very important questions. Go through them, try to find out the answer, put little force on your brain, by which you will have the entire understanding of the entire lecture. Okay, yeah. Thank you for watching this entire lecture and entire video. I'm really grateful. But again, yeah, there is one DSA session, the DSA 7 days DSA placement series going by the Baba Sukla sir. Go to the preference, search for it. And for deeper practices, you go here and search 150 not out Prepensta. Not out Prepensta. You will have good practice questions for free. Okay, good practice questions are free. So go there, check out them. Okay, and also if somebody want to upskill themselves, then you can refer the Prepensta Prime for sure. Okay, there you'll have 200 plus courses. Yeah, thank you everybody. Thank you for watching this entire video. It really meant a lot for me. How about you all? See you in the next lecture and tell me how was it.